In this video, you will learn how to find the percent and the whole. When we find the percent and the whole, we can use these strategies: models or percent proportions. Let's try a problem using models. 10 of the wrestlers on Johnson's wrestling team are in the 11th grade. This is 33 1/3% of the total number of wrestlers on the team. How many students are on the wrestling team? Because this is a word problem, my first step is going to be to use my nosy. I highlighted my question. Now I need to go back through and underline or circle any important information. I know that 10 of the wrestlers are in 11th grade and that is 33 1/3% of the total, but those are the only numbers I'm given. So sometimes it helps to break down a problem into what we know and what we need to find. Well, what do we know? We know that 10 wrestlers are in the 11th grade. And we know that that is 33 1/3% of the total team. What do you need to find? We need to find how many wrestlers total are on the team. Now, when we wrote what we knew from the problem, we said that there are 10 wrestlers in the 11th grade and that was 33 1/3% of the total. So we can rewrite 10 is 33 1/3% of the total, and we don't know what that number is. So 10 is 33 1/3% of what number? We need to identify what that number is. Well, in order to do that, we want to figure out what the part is and what the percent is so that we can find the whole. Well, if you remember our P times of, so P over 100 times of equals is, the part was back here at the end. So the percent times the whole equals the part. So that right there is the part. And remember, it's represented by the word is. And if we look at our problem over here, it says 10 is. So I know 10 is the part. And then it says the percent is. Well, we can easily identify the percent because there's a percent sign there. So the percent is 33 1/3%. And again, we need to find the whole. What we can do here is we can model 33 1/3% by dividing a number line into 3 parts, since 100 divided by 3 equals 33 1/3%. So we've done that. We have 33 1/3% on here. We have a line, a number line, and the whole thing represents the total, which is 100%. 33 1/3% is, it goes into 103 times, so that's why we've got those 3 sections there. And then we're going to go ahead and label the benchmark percent of 33 1/3% and its multiple. So 33 1/3% here. And then we have 66 2/3% here. So that's how our number line is going to be set up. Step 2 says write 10 at the 33 1/3% mark. So again, we need to make sure that our number line is labeled 33 1/3%, and it says write 10 at the 33 1/3% mark. So I'm going to write 10 there because we saw here that 10 is 33 1/3% of something. So that's where I got that number from. And then it says add 10 at each mark to find the whole. Well, this mark right here was 66 2/3%. And so I'm going to add 10. 10 plus 10 is 20, so 66 2/3% of something is 20. And then I'm going to add another 10, so 20 plus 10 is 30. And if we look, the number 30 is at the 100% mark. So this means 10 is 33 1/3% of 30. There are 30 students on the wrestling team. Now, models are great strategies to solve those problems, but we can also use something called a percent proportion. And you guys have been working with proportions, so this should not be entirely brand new to you. We have a problem here. 30 is what percent of 60? Well, we can use a percent proportion here to help us solve. What we're going to do is we're going to have the part be the numerator, and then the whole be the denominator of each ratio in our proportion. So, for the part, we have 30. 30 is what percent of 60? So the part here is 30. The whole is 60. So we're looking at 30 out of 60, and we want to know what percent that is. So we can write our proportion. Remember, a proportion is two ratios that are equivalent. So we have, again, to write the part on top. Well, the part is the P in percent. I don't know what that is right now, so I'm going to put an X there. Over the whole. Well, percents are always out of 100, so the whole here is going to be 100. I now have a percent proportion that I can solve to find X, which is the percent. So first thing we need to do when we have a proportion that we need to solve is simplify if we can. And I know that I can simplify this fraction right here. I know that 30 and 60 can both be divided by 30. 30 divided by 30 is 1, and 60 divided by 30 is 2. So I can go ahead and simplify, and it's 1 over 2. So now we have 1 over 2 is equivalent to X over 100. And I can easily solve this by saying, well, I know that I can take this 2 and I can multiply it times 50 to equal 100. And whatever I do to the bottom, I have to do to the top. 1 times 50 equals X. If 1 times 50 equals X and 1 times 50 equals 50, then 50 equals X. So our percent is 50, 50%. Let's try another one. 60 is 20% of what number? Now again, we're going to set up a percent proportion with the part on top and the whole on the bottom. So the part is 60. 60 is 20% of some unknown number. Well, we don't know the whole because that's what we're trying to figure out. We were given the part and the percent, but not the whole. So since I don't know the whole here, I'm going to write an X because that's our unknown value. It's a proportion, so I need my equal sign, and now I'm going to write the ratio for my percent. Well, that's basically my percent written as a fraction. 20 is the part out of 100, which is the whole. So 60 equals 20, or 60 over X equals 20 over 100. And I can solve this proportion, so why don't you go ahead and pause to solve and then press play to check. And once we solve, we find that the unknown is 300. So 60 is 20% of 300. 15 is 30% of what number? So we're going to set up our percent proportion, part over whole. And I know that 15 is the part, And it says 15 is 30%. Well, 30% is not the whole. I don't know what the whole is. That's the what number. So 15 over x equals 30%. 30 is the part. And then percent is always out of 100, so 100 is the whole. Now I have my proportion and I can solve. Why don't you pause, solve it, and then press play to check. 15 is 30% of 50. Now we have one more on this page. 225 is what percent of 300? I want you to set this up on your own and solve it on your own, and we will check it in class tomorrow. Let's go ahead and try some word problems. Peyton spent 60% of her money to buy a new television. If the television cost $300, how much money did she have? So I'm going to highlight my question, how much money did she have? And then I'm going to circle or underline the important information in the problem. She spent 60% of her money, and the television cost $300. So those are the numbers that I know. It's important for us to make sure we understand exactly what the question is asking us. Peyton spent 60% of her money on the TV, and the TV cost $300. That means that $300 is 60% of the money she had. So we can rewrite the problem. 60% of what number is 300? We need to find how much money she had total. So 60% of some number is 300. We need to solve. And if the problem was worded in a confusing way, then I rewrote it. 300 is 60% of what number? Well, we've seen problems like this before. We just practiced problems like this, and so we can set it up and solve easy. So we're going to do our percent proportion, the part over the whole, and then we're going to solve. So why don't you go ahead, pause the video, set it up, set up your percent proportion, solve, and then press play to check. Once I set up my percent proportion, I was easily able to solve. 300 was the part, I didn't know the whole, and I set that up equivalent to my ratio for the percent, which was 60 over 100. I simplified that ratio, and then I was able to solve my proportion. And so Peyton had $500. Before 1982, pennies were 95% zinc and 5% copper. If 100 pennies minted in 1980 have an approximate mass of 15 grams of copper, what is the total mass of 100 pennies? So we need to go ahead and highlight the question. What is the total mass of 100 pennies? Any other numbers that are important, I'm going to want to circle or underline. If they're not important, we should cross them out so they don't confuse us. It may be important to note that we are looking at copper. We don't need anything that has to do with zinc. So I'm going to cross out the zinc because I don't need to know that. It's going to confuse me. I don't want it to mess me up. I might use it on accident. So I'm going to cross it out. So the only numbers that I have to do with copper. 5% copper, 15 grams of copper. I also do not need to know how many pennies were minted. That doesn't matter. I'm not going to use that number in my calculations. I just want to know if those pennies have a mass of 15 grams of copper, what is the total mass of the pennies altogether? Doesn't matter how many there are, I just want to know the total mass. So now that I've done that, I can actually look at the information I've been given and I can clarify what's being asked of me. To solve, I'm going to need to set up a percent proportion where I have the part over the whole. and I trust you to be able to plug in the values yourselves and do your very best to solve, and we will check in class tomorrow. And there are no summary questions for this video, so once you have finished solving that problem, you are done.